Hi, welcome to Education World. This is Anjali and today I am going to tell about Numeric Python library that is NumPy. In this Python Numpy tutorial, we will understand each aspect of NumPy in the video. So, let's get started. What is a Python NumPy? NumPy is a Python package which stands for Numerical Python. It is the core library for scientific computing, which contains a powerful n-dimensional array object, provide tools for integrating C, C++, etc. It is also useful in linear algebra, random number capability etc. NumPy Array can also be used as an efficient multi-dimensional container for generic data. Let's check, how do I install NumPy? To install Python NumPy, go to your command prompt and type pip install NumPy. Once the installation is completed, simply import it by typing import NumPy as np. NumPy Array is a powerful n-dimensional array object which is in the form of rows and columns. We can initialize NumPy arrays from nested Python lists and access its elements. In order to perform these NumPy operations, there are two types of array: single-dimensional. I have import NumPy, then initialized NumPy.array1, 2, 3, and print this array. Moving ahead in Python NumPy tutorial, let us understand what exactly is a multi-dimensional NumPy array. Suppose I have different elements that are stored in their respective memory locations. It is said to be two-dimensional because it has rows as well as columns. Let us see how it is implemented. I have initialized an array with two tuples in a list, first tuple for rows and another is for columns values. It is two-dimensional array. Let's print this. Why do we use Python NumPy if we already have Python list? We use Python NumPy array instead of a list because of the three reasons. Less memory, fast, convenient. The very first reason to choose Python NumPy array is that it occupies less memory as compared to list. Then, it is pretty fast in terms of execution and at the same time it is very convenient to work with NumPy. So these are the major advantages that Python NumPy array has over list. I have import NumPy and sys. Then initialize list with range 1000 and check the allocated memory. After this, I have initialized an array with 1000 range and check the allocated memory. The output shows that the memory allocated by list, denoted by S, is 48,000 whereas the memory allocated by the NumPy array is just 4000. From this, you can conclude that there is a major difference between the two and this Next, let's talk how Python NumPy array is faster and more convenient when compared to list. I have import time and sys libraries. Then initialize del1 with sys which is 1,000,000 and same as L2 with the same size. Then generate list of tuple with L1 and L2. And check the time taken. Afterwards, moving forward in Python NumPy tutorial, let's focus on some of its operations. Ndim. You can find the dimension of the array, whether it is a two-dimensional array or a single-dimensional array. So, let us see this practically how we can find the dimensions. I have used ndim function to check the dimension of a NumPy array. With the help of ndim function, I can find whether item size. You can calculate the byte size of each element. In the code, I have defined a single-dimensional array and with the help of item size function, we can find the size of each element. The output is 4, so every element occupies 4 bytes in the type. You can find the data type of the elements that are stored in an array. So, if you want to know the data type of a particular element, you can use type function which will print the data type along with the size. In the example, I have defined an array where I have used the same function. As you can see, the data type of the array is integer 32 bits. Similarly, you can find the size and shape of the array using size and shape function respectively. Next, let us move forward and see what are the other operations that you can perform with Python Numpy module. We can also perform reshape as well as slicing operation using Python Numpy operation. But, what exactly is reshape and slicing? Reshape is when you change the number of rows and columns, which gives a new view to an object. Now, let us take an example to reshape the array. Suppose we have 3 columns and 2 rows, which has converted into 2 columns and 3 rows. Let me show you practically how it's done. Slicing is basically extracting particular set of elements from an array. This slicing operation is pretty much similar to the one which is there in the list as well. Before getting into the example, let's see a simple one. We have an array and we need a particular element, say 3, out of a given array. Here, the array 1, 2, 3, 4 is your index 0 and 4, 5, 6, 7 is index 1 of the Python Numpy array. Therefore, we have printed the second element from the 0th index. Taking one step forward, let's say we need the second element from the 0th and first index of the array. Let's see how you can perform this operation. Here colon represents all the rows, including 0. Now to get the second element, we'll call index 2 from both of the rows, which gives us the value 3 and 6 respectively. Next, just to remove the confusion, let's say we have one more row and we don't want to get its second element printed just as the image above. What we can do in such case? Consider the code. As you can see in the code, only 9 and 15 gets printed. Now when I have written 0:2, this does not include the second index of the third row of an array. Therefore, only 9 and 15 gets printed, else you will get all the elements i.e, 9, 15, 17. Linspace. This is another operation in Python Numpy which returns evenly spaced numbers over a specified interval. Consider the example. As you can see in the result, it has printed 10 values between 1 to 3. Max or min. Next, we have some more operations in Numpy, such as to find the minimum, maximum as well as sum of the Numpy array. You must be finding these pretty basic, but with the help of this knowledge you can perform a lot bigger tasks as well. Now, let's understand the concept of axis in Python Numpy. As you can see in the figure, we have a Numpy array 2 times 3. Here the rows are called as axis 1 and the columns are called as axis 0. Suppose you want to calculate the sum of all the columns, then you can make use of axis. Therefore, the sum of all the columns are added where 1 plus 3 equals 4, 2 plus 5 equals 7 and 3 plus 6 equals 9. Similarly, if you replace the axis by 1, then it will print 6, 15, where all the rows get added. Square root and standard deviation. There are various mathematical functions that can be performed using Python Numpy. You can find the square root, standard deviation of the array. So, let's implement these operations. As you can see the output, the square root of all the elements are printed. Also, the standard deviation is printed for the array i.e, how much each element varies from the mean value of the Python Numpy array. Addition operation. You can perform more operations on Numpy array. It is addition, subtraction, multiplication and division of the two matrices. Let me go ahead in Python Numpy tutorial and show it to you practically. This is extremely simple, right? Similarly, we can perform other operations such as subtraction, multiplication and division. Consider the example. Vertical and horizontal stacking. Next, if you want to concatenate two arrays and not just add them, you can perform it using two ways: vertical stacking and horizontal stacking. Ravel. There is one more operation where you can convert one NumPy array into a single column I.ravel. Let me show how it is implemented practically. Let's move forward in Python Numpy tutorial, and look at some of its special functions. Special functions, Python Numpy special functions. There are various special functions available in Numpy such as sine, cosine, tan, log, etc. First, let's begin with sine function, where we will learn to plot its graph. For that, we need to import a module called matplotlib. To understand the basics and practical implementations of this module, I have defined x as in NumPy array and y with sin of x. This is the output plot. Similarly, you can plot a graph for any trigonometric function such as cos, tan, etc. Moving forward with Python Numpy tutorial, let's see some other special functionality in NumPy array such as exponential and logarithmic function. Now in exponential, the e-value is somewhere equal to 2.7, and in log, it is actually log base.
The exponential values are printed I.e raised to the power 1 is e, which gives the result as 2.718. Similarly, e raised to the power of 2 gives the value somewhere near 7.38, and so on. Here, we have calculated natural log, which gives the value as displayed above. Now, if we want log base 10 instead of lane or natural log, we have covered all the basics of Python Numpy, so you can start practicing now. The more you practice, the more you will learn. Please ask your doubt in comment, keep practicing and subscribe this channel.